Good morning, students. Here are important multiple choice questions for not only CET but for other competitive exams also. I have selected important questions from the first topic of second PU, that is solid state. So there are some instructions you have to follow before we start this lesson. So you'll have to take a notebook and pen. Already you have received the hard copy, or that is the downloaded version of the questions, multiple choice questions. You keep it ready or note down it in the book. And after every question with multiple answers, you leave some gap so that the working part, the calculation part, you can write under that. So now the slides are like this. The first slide will be the question with multiple choice answers, and the following slide, the next slide, is the answer slide, where you have all the working and explanations. So you can go through first question, work out the answer, then you see the answer slide, find out the answer, what you have marked and what is there in that answer. Then you have to see the working part, the explanation part. If possible, note down them and remember them. So all these questions are picked from the previous important examinations. So we start with the very first question. All the best. So which of the following solids generally have highest melting point? So I'll give the clue, the hint. Melting point of a solid depends upon the nature of bonding, the bonding between atoms or molecules, ions in that. Ionic solids are bound by electrovalent bond. Covalent solids bound by covalent bond, that is sharing of a pair of electron. Metallic solids have metallic bond, and molecular solids, the different type of bonds like van der Waals forces, hydrogen bonding, etc. But what you have to use here is the idea of examples. Example for ionic solid, NaCl, covalent solid, I take diamond, metallic solid, iron, then molecular solid, ice. And if you just have a common sense, that is their melting points, and you find that diamond has got the very high melting point, the reason can be taken like this. So look at the answer. Yes, the answer is covalent solids have highest melting point. Look at the example. The diamond has a network of carbon atoms with strong directional and rigid covalent bonds. So you have that. I'll just show you the arrangement here. So here is the carbon that is bound by 4 other carbon atoms tetrahedrali, and it is so rigid. The bonds are so rigid, directional and strong. So diamond has got a high melting point. So that makes us the answer, select the answer, covalent solids. Which of the following will show anisotropy? So here is a property known as isotropy, where if you measure some of the properties in a solid along different directions, it must give the same value. Isotropic solids give same value for a property measured in different directions. So which type of solids show that? Amorphous solids have that property, isotropy. And among the answers, you have to pick that solid which is crystalline. So got it? Look at the answer. Iodine is crystalline. So since it is crystalline, it doesn't show isotropy. Anisotropic. In FCC lattice, the number of nearest neighbors for a given lattice point are. The other meaning of the number of nearest neighbors is the coordination number. So coordination number. So you'll have to find out FCC, how the constituents are arranged. If there is a constituent here, it is surrounded by 6 other constituents in the same plane, 3 above and 3 below. So every constituent now is surrounded by 6 in the same plane, 3 above, 3 below. That makes it the answer 12. Let us find out. Yes, the answer is 12. It is the coordination number in FCC. Here is another question. Line solid anion Y are arranged in cubic close packing. CCP can be taken as FCC. The two abbreviations represent the same thing. You call it cubic close packing or FCC. So cation X are equally distributed between octahedral and tetrahedral voids. If all the octahedral voids are occupied, the chemical formula of the solid is. So now you know chemical formula of the solid depends on the two components X and Y, the ratio. You have to find out the ratio of X to Y. Now you know anion Y are arranged in cubic close packing. FCC means you know the number, their number. Then cations occupy distributed between octahedral, tetrahedral voids. All octahedral voids are occupied, but the number of octahedral and tetrahedral voids differ. So you have the clue. Here, let us find out. Look at the answer. It is 2:1. X is to Y is 2:1. It is X to Y. Then points. In CCP, there are, if the number of anions are N, let us say take anions in that are N. Let us know that number. The number of octahedral voids, it is same. The number of octahedral voids created are equal to the number of constituents Y. But the number of tetrahedral voids, the number of tetrahedral voids are double that number. So that is 2n. But all the octahedral voids are filled n, and equal number of that octahedral tetrahedral voids are filled andre adu n plus half 2n, that is n plus n, that comes to 2. So the proportion of X to Y is 1. Come to next question. A compound formed by elements P and Q crystallizes in cubic lattice, where P atoms are at the corners and Q atoms are at the body center and alternate phase centers of the cube. The formula of the compound is, now the ratio of P and Q you have to find out. You can find the ratio of the two components of a solid not only by using voids filled, you can also find out that by the positions of the constituents, corner constituents. If the constituents are at the corner, let me write. If the constituents are at the corners, so you have this. So it will be 1/8 of 8 constituents. And if there is the body center constituent, it is 1 full. The body center constituent is not shared with other constituents. And there is one more thing given, alternate phase centers. I'll show you that, how that comes. Alternate phase center andre cube nalli hege baratte ennodu torustini. If this is the cube, so alternate phase center will be 1 here and 1 here. That's all. So how much is the share of this? There are two components. It is 1/2 of 2. Now look at this. How many P's and how many Q's are there? Lekka hakondre iga answer barutte. Look at this. P is to Q is 1:2. Look at that. In the cubic corners, there are 8, body center 1, and alternate phase centers 2. P is only at the corner, that is 1. Q will be at the body center 1 and half the 2 alternate phase centers, that is 2. So you write that as P, Q, 2. So the next question. Copper crystallizes in FCC lattice with a unit cell edge length of 361 picometer. What is the radius of the copper atom? So look at this. They have given the unit cell edge length and you are required to find the radius of the atom. So I'll draw this diagram for you. If this is the copper atom, here is the radius. And if the unit cell is like this, I'll draw the unit cell also. And edge length is A. We'll have to relate R with A. And in FCC, what is the type of arrangement? I'm going to write it here. It is one of the faces. This is face diagonal, and these are the positions. How the constituents are arranged on the face diagonal is one here, and one here. The radius R, 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 and R. And face diagonal, we represent this as B. Edge length is represented as A, and it comes to a right angle triangle. So we apply the Pythagoras theorem. B square is A square plus A square. That comes to 2A square. Then B is root 2A. Then we have B value in terms of radius R. So B, the length B consists of 4R. Now you can relate this with this. And what is given is radius, and what you have to find is A. Let us see. So the fourth option, 128 picometer, is the answer. Now look at this. In FCC, edge length A, face diagonal B, then B square is 2A square, B is root 2A, 4R. So R radius, the radius now, it comes to this radius. You can substitute the value of A. So that comes to 128 picometer. Now the next question, percentage of free space, unoccupied space in CCP or FCC and BCC. They are comparing the two. They are comparing the two forms of the solid, FCC and BCC. To know the percentage of free space, we'll have to know the packing efficiency. So that means packing efficiency is the space occupied, empty space is 100 minus that. So as you know, FCC packing efficiency and then 100 ali kadibek. So that is 74% and 68%. If you subtract it, you get that as the answer. So let us see. Yes, empty spaces 26%, 100 minus 74, and BCC nulli, it is 68%, 100 minus 68. Next question. The total volume of atoms of radius R in FCC unit cell. Again, you have the FCC unit cell. So that, let me write the atom with radius R. Next, we have in FCC, the volume occupied by all the atoms. Total volume means volume occupied by all the atoms you will have to take. So that means you have to take the volume of one atom 4 by 3 pi R cube. And how many atoms make up one unit cell? That is important. So in FCC, we represent the Z as 4. So that means 4 times this into this. That is the total space of all the atoms together. That is the total volume occupied by all of them. So let us look at the answer. Yes, it is 4 times 4 by 3 pi R cube. That is 16 pi R cube by 3. So 4 atoms per unit cell. Total volume is 4 into 4 by 3 pi R cube. If the unit cell edge length of an FCC crystal with molar mass 58.5 grams per mole is 600 picometer, then the density of the crystal is. So to answer this question, you need to use the formula. I'll just write the formula here. It is D, the density depends upon Z, number of constituents per unit cell, molar mass, then A cube, that is A is the edge length of the unit cell, cube of that Avogadro number. So you need to substitute this, this, this. And for this, you need to convert. Look at the unit. Unit in the answers. Answer nalli unit nodi, grams per cc ಇದೆ. cc, cubic centimeter. ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಯಾವುದು? The unit for the length is picometer. You need to convert that into picometer. So that is picometer ಗೆ convert ಮಾಡಬೇಕು. So you have this 600 picometer. You write it as 600 into 10 to minus 12 meter. Then that makes it 600 into 10 to minus 10 centimeter. That is simply 6 into 10 to minus 8 centimeter. You need to substitute this in the formula. Let us see the answer slide. Look at this. The answer is first option, 1.79 grams per cc. So the formula goes like this. Look at this. Zm A cube Na 4 into 58.5 divided by 6 into 10 to the power of idu A cube idu. Amele idu Avogadro. So look at this. ಈ ತರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಅಲ್ಲಿ ಅವೈಗಡ್ರೋ ನಂಬರ್ ನ ಜಸ್ಟ್ 6 ಅಂತ ತಗೋಬಹುದು. ಸೊ ದಟ್ ದ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಬಿಕಮ್ಸ್ ಈಸಿ. 6 into 10 to 23 ತಗೋಬಹುದು. ಸೊ ದಟ್ ಕಮ್ಸ್ ಟು 1.8. ನಿಯರೆಸ್ಟ್ ಆನ್ಸರ್ ಇಸ್ 1.79. Now the next question is the number of atoms in 100 grams of FCC crystal of density 10 gram per cc and unit cell edge length 200 picometer. To solve this problem, you will have to use the same formula. So that is density equals Z m over A cube Na. So what is not known here is m. You'll have to find this. And if you know the molecular formula, so from that you can find how many atoms. So idu 1 mole adre 1 mole nalli it is Avogadro number of atoms. Let me write 6 into 10 to 23 atoms, and then you find it for 100 grams. So you need to divide this by mole and then into 100. So let us see the calculation part. Look at this. The answer is 5 into 10 to 24. So look at the steps. You have here the formula. Density, molar mass is density into Avogadro number into A cube divided by Z. And for FCC, Z is 4. Density as is given. Density kotidare. Then Avogadro number 6 into 10 to 23. So idinna simplify madadre idu barutte. So this is molar mass. So that 1 mole contains Avogadro number of atoms. Then how many atoms are there in 100 grams? If you simplify this, you get the answer 5 into 10 to the power of 24. Next question. A metal M crystallizes in FCC or BCC depending upon the temperature. The ratio of its densities in FCC and BCC. Look at this. A particular metal will not have a definite crystal structure. The crystal structure depends upon the temperature. So it is temperature dependent, whether it is FCC or BCC. Now we'll have to find the densities, compare them. Ratio andre density na compare madbeku. So I'll just write here this clue. Idu FCC one crystal adre, idu BCC ade metal innond crystal. Z1, Z2, let me take, compare ಮಾಡಿ. Either density D1, D2. What else will differ? ಇನ್ಯಾವುದು ಡಿಫರ್ ಆಗುತ್ತೆ? ಎಡ್ಜ್ ಲೆಂತ್ ಡಿಫರ್ ಆಗುತ್ತೆ. ಆ ಯೂನಿಟ್ ಸೆಲ್ನ ಎಡ್ಜ್ ಲೆಂತ್ ಇಟ್ ಇಸ್ A1, A2. ಸೊ ಓನ್ಲಿ ದೀಸ್ ಡಿಫರ್. ಬಟ್ ದಿ ಅದರ್ ವ್ಯಾಲ್ಯೂಸ್ ಯಾವುದು ಕಾಮನ್ ಇರೋದು ಯಾವ್ಯಾವುದು ಅಂದರೆ it is m molar mass is same for that, and then Avogadro number is same for that. So except this, you'll have to use this and compare. So density can be related to these. It is proportional to Z by AQ. So from the formula of density, you can compare the density with number of constituent per unit cell and A cube, the length of the edge cube. So now let us see the answer and working. Yes, the answer is 8 divided by 3 root 6. 8 by 3 root 6 you get. So look at the working. It is same density formula. So as I told you, M and this M and Na are same for both structures. So density is directly proportional to Z inverse to A cube. So if you substitute them as 1 and 2, ಎರಡು ಕೇಸಲ್ಲಿ 1 and 2 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ ಡೆನ್ಸಿಟಿಗೆ ಕೊನೆಗೆ ಇದು ಫಾರ್ಮುಲಾ ಈ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಬರುತ್ತೆ. That can be further simplified as finally the answer 8 divided by 3 root 6. So I'm going to send answer and working document also after the class is over. Class ಆದಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಡೇ ಆನ್ಸರ್ ಅಂಡ್ ವರ್ಕಿಂಗ್ ಕಳಿಸ್ತೀನಿ, ಅದನ್ನು ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೋಬಹುದು, ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. A compound AB crystallizes in BCC lattice with unit cell edge length of 480 picometer. Then the radius of B minus is 225 picometer, and what is the radius of A plus, they are asking. So this compound is formed by the two constituents. It is formed by the two constituents. So that is A plus cation and B minus anion. So normally we say that, so the radius cation and anion eradu arrange adre hega arrange agutte BCC andaga, for anion it is BCC, anion BCC andaga it is present in the corners of the cube, corners as well as at the center of the cube. Then the edge length of the BCC you take, for example, idu edge length A adre, idu face diagonal. One more thing I'll show you. This is face diagonal B, and body diagonal will be the other one. I'll just write this. Idu know the edge andre. This is C. You need to relate C with A. So you get the answer like it is C square is 3A square, can take it. Then C is root 3A. Then see how the constituents are arranged on the body diagonal. If this is the body diagonal, diagonal from one corner of the cube to the other corner. So how this anion B is here, cation A illondu, cation A illondiru. So this is 1A plus another A plus. So now you can take this, idu radius of the B, idu radius of the A. So the clue is that this C is C idiyalla, the length of the body diagonal is 2R plus 2R minus. It is the sum of the double radius of the cation and double radius of the anion. So from that you are going to find R plus when you know R minus. So let us know the answer. Look at this. The answer is 190.7 picometer. So in BCC, C is the body diagonal. So C is the body diagonal. A is the edge length. How they are related, another kotidare, it is this. And R plus, you get this formula. So substitute R minus, you get 190.69 rounded to, so 190.7 picometer. Here is another interesting question. The unit cell edge length of NaCl crystal is 564 picometer. Its density would be, it's a direct question with the formula. Z M over AQ, then NA. So what they have given is this. Again, convert that picometer into centimeter. You'll have to convert it first to meter, then centimeter, substitute that in centimeter. Then Avogadro number, 6 into 10 to 23. Molar mass of NaCl, it should have been given here, but it is 58.5 grams per mole. Then Z, FCC, it is NaCl is known to be FCC. The Z value is 4. All of them, you can find the density. So let us see the next slide. Answer, yes. ZmNaAq. So 4 into 58.5 by Avogadro number into the picometer in centimeter. Illi substitute ಮಾಡಿದೀವಿ. So that comes to 2.17. But the answer is nearest. You may not get the exact answer when calculated. So the answer is 2.165 grams per centimeter. The distance between an octahedral void and a tetrahedral void in FCC lattice would be, it's a very, very tricky question. Both the voids are there in the FCC lattice. You'll have to find the gap between one tetrahedral void and one octahedral void. So the clue can be shown in the diagram. I'll show you the diagram here. So I'll write the cube for you. So straight line barta illa. Okay, no problem. Gottagate position. You can draw it on the paper. So practice writing cube because many questions depend upon these diagrams. So this is, I divide the cube into two parts. Ellanu divide ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. Every plane I am going to divide into two parts. So ಈ ತರ divide ಮಾಡ್ಕೊಂಡ್ರೆ now you locate voids ಎಲ್ಲೆಲ್ಲಿ ಬರುತ್ತೆ ಅಂತ. Octahedral voids. Octahedral voids are found here on the edge lengths. So this is ಎಲ್ಲ edge length ಅಲ್ಲೂ octahedral void ಬರುತ್ತೆ. Exactly at the center of the cube ಒಂದು octahedral void ಬರುತ್ತೆ. So then tetrahedral voids ಇಲ್ಲಿ ಬರುತ್ತೆ. ಈ small big cube is converted into so 4 above and 4 below small cubes. At the center of each cube you get tetrahedral voids. ಈ small cubes na centers ನಲ್ಲಿ tetrahedral voids ಬರುತ್ತೆ. So you have tetrahedral voids at the centers of these small cubes. Now you have to take the diagonal. ಯಾವುದಾದರೂ ಒಂದು diagonal ತಗೊಳ್ಳಿ. So body diagonal ತಗೊಂಡ್ರೆ you find both octahedral void and tetrahedral voids ಎರಡು ಬಂದಿದೆ. ಈ ಗ್ಯಾಪ್ ನ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕು. So now I show you the working. Look at this. The two voids are on the body diagonal C. And C is related to body diagonal is related to edge length A like √3a. So the distance between them, yes, baratte body diagonal again I am going to write here. This is C. Here there is the octahedral voids. Here there is one tetrahedral void. Here there is another tetrahedral void. This is octahedral void. So you can divide this into 4 parts. Then gap between them, it is 1/4 of this C. That is the answer. So the answer is √3a by 4. That is 1/4 of C. A binary solid AB has NaCl type of structure. If all ions are removed from one of the body diagonal planes, the new formula becomes, look at this idea. The formula of the compound depends on the ratio of atoms. In NaCl, the ratio of Na plus Cl minus is 1:1. And even this compound given in the question AB has a ratio 1:1. What they are removing is all the ions from the body diagonal. I'll write the structure of the body diagonal. Look at this. Again, a cube. Yes, I'll mark a body diagonal and plane, not body diagonal, it is body diagonal plane. So this is the body diagonal plane. Did you understand this? All the ions that come on this body diagonal has been removed. Then you can answer this in two ways. Anyway, the formula of the compound depends on the coordination number of Na plus and Cl minus. Let me write coordination number Na plus and Cl minus. It is 4 and 4. 4 Na plus surrounds 1 Cl minus, 4 Cl minus around 1 Na plus. Idukku adhe tarane barutte. So when you remove this, the coordination number will not change. So the formula will not change. Another argument is when you remove the ions from this plane, you are removing equal number of both the ions. ಎರಡು ions na equal number alli remove ಆಗೋದ್ರಿಂದ ratio ಹಾಗೆ ಇರುತ್ತೆ. That formula remains same. Let us find out. Yes, the formula remains same. Equal number of cation and anion are removed. No change in formula. So here is a very, very important calculation involving defects in solids. Solid defects alli illi ಏನು defect ಇದೆ ನೋಡೋಣ. In Fe 0.940, the fractional presence of ferrous ion is, what you have to find here is how many ferrous ions to total number of iron ions. And you know, there are two types of ions for iron. Iron nalli ಎರಡು ತರ ions ಇದೆ ಅಲ್ವಾ, ಒಂದು ferrous, ಇನ್ನೊಂದು ferric. If all the ions are ferrous, the formula of the ferrous oxide would be this 1:1. Now it is given 0.94:1. So number of ferrous iron ion have reduced because some of the ferrous ions have been converted to ferric ions. Easily ferrous gets oxidized to ferric. So now in this compound, what you have seen here, 0.94:1. ಇದೆಲ್ಲ ಇದರಲ್ಲಿ ferrous ions ಮಾತ್ರ ಇಲ್ಲ, ಸ್ವಲ್ಪ ferric ions ಇದೆ. And you have to find the ratio of number of ferrous ions to the total number of all the iron ions. ಎಲ್ಲ iron ions na ಕಂಪೇರ್ ಮಾಡಿ ferrous ions ಎಷ್ಟಿದೆ, ರೆಡ್ಯೂಸ್ ಆಗಿರುತ್ತೆ ferrous ions, ಅದನ್ನ ಈ ರೇಷಿಯೋನ ಆನ್ಸರ್ ಅಂತ ಬರೀಬೇಕು. Now let us see the calculation, very important. Yes, it is 41:47. So that means, let me show you here. If 47 iron ions are there, among them only 41 will be ferrous. It will be ferrous. So now let us see the steps. From the formula, 94 iron ions correspond to 100 oxide ions. So 0.94:1 na 10 times ಮಾಡ್ಕೊಂಡ್ರೆ 100 times ಮಾಡ್ಕೊಂಡ್ರೆ 94:100. Then charge on all the oxide ions is -200. Charge on all the iron ions will be +200 because a compound is neutral. Total plus and total minus must be equal. Then let us assume there are X ferric ions and 94 minus X ferrous ions. You divide among the total ions. X is the ferric. Fe plus 2 ne 94 minus X anta ಮಾಡ್ಕೊಳ್ಳಿ. Then you divide the total charge of -200 between them. So that is the problem, mathematics. Plus 2 ions ಎಷ್ಟಿದೆ into 94 minus X. Plus 3 ions ಎಷ್ಟಿದೆ X. So that is equated with plus 200. Now you get from this the value of X. And the value of X represents ferric ions. And from that you find the ferrous ions. And take the ratio of total number of ions to ferrous ions. Idನ್ನು simplify ಮಾಡಿದಾಗ, simplest form ಗೆ ತಗೊಂಡ್ಬಂದಾಗ, it is 41:47 ಬರುತ್ತೆ. So that is the answer. So which of the following sets contains only ionic solids? Now the clue is that The clue is that if you have metal, a metal that can easily lose electrons and become an cation, that is Mn plus. So whenever metals are involved in the solid formation, the bond will be mostly ionic. Even one atom is metal, the bond will be ionic. If there are only non-metals involved, if the solid is formed by only non-metals, the bond between non-metal atoms is by the sharing of electrons. When sharing takes place, the bond will be covalent. So now you have to look for those, that group where all of them are containing one of the metals in the compound. So that choice, here it is non-metal, 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 illustrine. So have this non-metal, non-metal, illustrine, non-metal, non-metal. So the one without non-metal, non-metal, andre eradu non-metal ilde irodu idikke barutte. So let us see the answer. Look at this. Yes, the first option, NaCl, MgO, ZnS. They are the solids of only non-metal atoms without a metal like SiO2, SiC are covalent. The number of tetrahedral voids present on each body diagonal in CCP unit cell. So again, you require a clue, that is a diagram. So I'll write a cube for you. You'll have to write it on the book, page mele barkoli. Mark the body diagonal. How many body diagonals you can draw here? It is 1. It is 2. It is 3. Innondu yavadu barutte? It is 4. So 3 illindu 4. So there are 8 body diagonals. So let me write body diagonals. And where do you locate the tetrahedral voids? Nanagale held 1, 2, 3, 4, 5, 6, 7, 8. If the cube, the bigger cube is divided into 8 small cubes, at the center of each small cube, a small cube ಬರುತ್ತಲ್ಲ ಇಲ್ಲಿ, ಆ small cube ನಲ್ಲಿನೇ ಒಂದೊಂದು tetrahedral. So one the body diagonal ಅಲ್ಲಿ you have one this, one. So it is 2 tetrahedral voids. Let us see the answer. Yes, it is 2. In a CCP or FCC lattice, there are 8 tetrahedral voids and 4 body diagonals. And they have asked one body diagonal, that is 2 tetrahedral voids. Next question. The number of octahedral voids present per unit cell of CCP. How do you calculate this? Octahedral voids depend upon octahedral voids. So let me write it like this. Voids octahedral. It depends upon the number of atoms that make up that crystal. So CCP nalli, per CCP or FCC unit cell, how many atoms count for one unit cell? It is 4. So the number of octahedral voids will be equal to this. Let us see. So it is 4. Yes. Octahedral voids is equal to 1. Ellide adu 1 at the body center, exactly at the center of the cube nal ondirutte. Amele 12 edge centers nalli irutte, that is 1/4, because a constituent at the edge center will be shared by 4 unit cell. So the portion that comes to 1 unit cell is 1/4. Atara ಎಷ್ಟು ಇರುತ್ತೆ into 12. So that is 3. It is 1 plus 3, that is 4. The packing efficiency in simple cubic unit cell. Very simple formula. So we have here packing efficiency. Andre how many volume, the total out of the total volume in the cube, how much of is filled with constituents? That is a formula here. It is Z V by a cube. So what are these? It is number of constituents per unit cell. How many atoms are there? This is total volume of one sphere. Let me say this is total volume of idu melgadedu volume occupied by the constituent. ಇದು actual volume of the cube where A is the edge length. So A cube, length into breadth into height, ಇದು ಬರುತ್ತೆ. So if you find out this, how much exact value ಕೇಳಿಲ್ಲ ಇಲ್ಲಿ, the final formula without substituting pi. Pi ನ value ತಗೊಂಡಿಲ್ಲ ಇಲ್ಲಿ. ಹಾಗೆ ಇದೆ pi, ನೋಡೋಣ. Yes. So packing efficiency is, it is ZV by A cube. Z is 1 because you calculate for simple cubic 1 constant per unit cell. So it is 1 constant per unit cell. So volume of each sphere atom is this. So A is 2R. 2R, andre how that is related, I'll show you here. It is the edge length A. ಒಂದು ಕ್ಯೂಬ್ ನ ಲೆಂತ್ A ಆದರೆ ಎಲ್ಲೆಲ್ಲಿರುತ್ತೆ ಸ್ಪಿಯರ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಸ್ಪಿಯರ್, ಇಲ್ಲಿ ಒಂದು ಸ್ಪಿಯರ್. So there are two constituents at the two corners. Idu R, idu R. So the A comes to 2R. So now from that you get final answer 4 by 24 pi andre divide. It is 1/6 of pi. The correct relation for radius of an atom and edge length of unit cell of FCC lattice. So again here we have the type of unit cell. The crystal is FCC. They have a radius and edge length to be related. So radius and edge length, how do we relate this andre? Idu ಒಂದು atom radius R. So edge length andre hege ತಗೋತೀವಿ andre, it is A. How that is arranged ಅನ್ನೋದು ತಗೊಂಡ್ರೆ, you take one of the faces. One of the faces you take. ಒಂದೇ ಫೇಸ್ ಸಾಕು. ಫೇಸ್ ಡಯಾಗನಲ್ ತಗೋಬೇಕು. FCC ಗೆ ಫೇಸ್ ಡಯಾಗನಲ್ is important. B ಅಂತ ತಗೊಳ್ಳೋಣ ಅದನ್ನ B. Let me write. ಇದು A, ಇದು A, ಇದು A, ಇದು A. So how are the constituents arranged ಅಂದ್ರೆ FCC ನಲ್ಲಿ ಹೇಗೆ ಅರೇಂಜ್ ಆಗಿರುತ್ತೆ? ಒಂದು ಮಧ್ಯ, ಇನ್ನೊಂದು ಕಾರ್ನರ್, ಇನ್ನೊಂದು ಕಾರ್ನರ್. I'll draw that for you. 1, 2, and 3. So R, 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 and R. So now you take this as the right triangle. So B square is 2A square. So B is root 2A. Then in terms of R, B ಎಷ್ಟಿದೆ? 1, 2, 3, 4. So that is related to B as 4R. Then you relate these two. So it is R is equal to root 2 by 4. Root 2 by 4 A baratte. So that means you can divide this. Idana 2 into 2 anta madkondre. It is 2 into 2 madkondre. So this 2 root 2. So now you see the answer, and it's A by 2 root 2. Face diagonal B, edge length A, B square is 2A square, B is root 2A, 4R, R is root 2A by 4. So the next question is, gold crystallizes in CCP structure. Cubic close packing is same as FCC. The total number of voids in 197 gram gold. Atomic mass is 197. You look at those values. So ಈ ವ್ಯಾಲ್ಯೂ ನೋಡಿದ್ರೆ ನೀವು, ಈ ವ್ಯಾಲ್ಯೂ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಇದು ಕ್ಲೂ ಈಸಿ ಅಂತ ಅನಿಸುತ್ತೆ. ಸೊ ಅಟಾಮಿಕ್ ಮಾಸು 197 ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ನಾವು ಮಾಸ್ ಆಫ್ ಗೋಲ್ಡ್ ತಗೊಂಡಿರೋದು 197 ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ ಹಿಯರ್ 197 grams gold. So simplification becomes easy. How do we do this ಅನ್ನೋದು ನೋಡಿದ್ರೆ, now you find out FCC ನಲ್ಲಿ Z ತಗೊಳ್ಳಿ, ಎಷ್ಟು atoms count for one unit cell? It is 4. Then voids, the total number of voids ನಲ್ಲಿ ಎರಡು ತರ ಇದೆ. So it is void octahedral, let me mark it as this, and void tetrahedral. Number of atoms ಗೆ voids relate ಆಗಿದೆ. Octahedral voids will be same as this 4. Alva? Tetrahedral voids ಗೆ it is 2 times 4, that is 8. But here, what you have here, the mass, ಇದು 1 cubic unit cell ಅಂತ ತಗೊಂಡಿಲ್ಲ. It is mass is 197 grams. ಇದು 1 mole ಆಗುತ್ತೆ. Look at this. 1 mole ಅಲ್ಲಿ ಎಷ್ಟು atoms ಇರುತ್ತೆ ಅಂದ್ರೆ it will be not just one unit cell, it's more number of unit cells. So it is number of unit cells 1 ಇಲ್ಲ, ಎಷ್ಟಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ atoms ಎಷ್ಟು ತಗೋತೀವಿ, ಅವೊಗಡ್ರೋ ನಂಬರ್ ತಗೋತೀವಿ. ಸೊ ಇದರ ಬದಲು ಇದನ್ನ ತಗೊಂಡಾಗ it is Avogadro number of octahedral voids 2 times Avogadro number of tetrahedral voids. Erudunu add madidre you get this 3. So let us see this working. Yes, 3 times Avogadro number. So 197 grams amounts to 1 mole. In 1 mole is Avogadro number. Number of octahedral voids is Na, number of tetrahedral 2 times Na, that comes to 3 times Na. Yes, here is a very interesting calculation. In NaCl, there are so many Schottky pairs per cc at room temperature. So Schottky pairs per 1 cc nalli ಎಷ್ಟು Schottky pairs ಇದೆ. Schottky pair here they mean the Schottky defect pairs. So I'll write that Schottky defect na hege annodu nanili torustini. So in NaCl there are Na plus ions and Cl minus ions. So they are arranged in alternative. So that is Cl minus Na plus, Cl minus Na plus. One more layer will be there. It is Na plus, Cl minus, Na plus, Cl minus. So it is without defect. Suppose one cation is missing, proportionately one anion will be missing. One cation, one anion miss adre, idu one Schottky pair anta kare. It is Schottky defect pair. It is void. Idana cationic void antivi, idana anionic void. Athara ಎಷ್ಟು voids per cc andre 1 cc nalli ide anta lekka hakbeku. That's very interesting. So now you know how many Schottky defects are there in a known number of atoms. So adanna naniga nimage calculation alli torustini. Look at this. The answer is 10 to 6. So they have found from calculation, you know, 1 cc of NaCl would contain 10 to 22 ions. ಇದನ್ನ ಹೆಂಗೆ ಲೆಕ್ಕ ಹಾಕ್ತಾರೆ ಅಂದ್ರೆ ಅವಗಡ್ರೋ ನಂಬರ್ ಮೋಲ್ ಇಂದನೇ ಲೆಕ್ಕ ಹಾಕಿದ್ದಾರೆ. 10 to 22 ಟೋಟಲ್ ಅಯಾನ್ಸ್ಗೆ 1 cc NaCl ಆಗುತ್ತೆ. Then they have also found out that if there are a total of 10 to 16 ions together, Na plus and Cl minus 10 to 16 ions idre, one pair miss ಆಗಿರುತ್ತೆ. One Schottky defect pair for 10 to 16 ions. Then you convert this to 1 cc. Ions na cc convert ಮಾಡಬೇಕು. ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ 10 to 16 ions ಗೆ 1 Schottky defect pair ಆದರೆ 10 to 22 ions ke S2, because 10 to 22 ions will be in 1 cc. So the answer will come to 10 to 16. Next question is, if NaCl is doped with 10 to minus 4 mole percent of SrCl₂, the concentration of cation vacancies. Here is again a question on solid defects. What type of defect is this? It is called impurity defect. Impurity defect. What is the impurity? Let me write Na plus crystal without defect. So it is Na plus. So I'll write Na plus, Na plus. One more line I would like to write Na plus, Na plus. Suppose this pure crystal of sodium chloride, it is made impure by adding strontium chloride. So what is there in strontium chloride is the strontium ion. So let me write how that replaces this. So strontium plus 2 ತಗೊಂಡ್ರೆ ಅದು ಎಲ್ಲಿ ರಿಪ್ಲೇಸ್, ಇಲ್ಲಿ ಅಯಾನ್ಸ್ ನ ರಿಪ್ಲೇಸ್ ಮಾಡುತ್ತೆ. ದಿಸ್ ಇಲ್ಲಿ ನಾನು ಇದು ಒಂದು ಅಯಾನ್ ಹೋಗಿ ಇಲ್ಲಿ ಸ್ಟ್ರಾನ್ಶಿಯಂ ಪ್ಲಸ್ 2 ಬಂದ್ರೆ, ಲುಕ್ ಅಟ್ ದ ವೇಲೆನ್ಸಿ. ಇದು +1, ಇದು +2. ಇದು ಒಂದು ಜಾಗ ಖಾಲಿ ಮಾಡಿದ್ರೆ ಇದಕ್ಕಾಗಲ್ಲ, ಇದು 2 ಜಾಗ ಖಾಲಿ ಮಾಡಿ ಇಲ್ಲೊಂದು. ಸೊ 2 Na plus are removed and 1 Sr plus 2 is replaced. ಸೊ ಇದು ಫಿಲ್ ಆಯ್ತು, ಆದರೆ ಇದು ವೇಕೆನ್ಸಿ ಆಗುತ್ತೆ. Now you know number of vacancies cation vacancies is equal to number of strontium ions added. And number of strontium ions added depends on its concentration, and its concentration is given in mole percent, mole per 100 ಕೊಟ್ಟಿದೆ. ಅದನ್ನ ನಾವು ಮೋಲ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಅದನ್ನ ನಂಬರ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ number of vacancies-ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. So got the clue? Now you see the answer. Look at this. So the answer is second option, 6.02 into 10 to 17 mole per mole, sorry, 6.02 into 10 to 17 per mole. So now you know 1 strontium plus 2. Each strontium plus 2 replaces 2 sodium plus 2 ions and leaves 1 cation vacancy. So therefore, concentration of cation vacancies is equal to concentration of strontium. So look at the concentration of strontium here. Mole percent andre for 100 andre 10 to minus 4 mole strontium in 100 mole sodium ions. So now you convert this 100 moles ge 10 to minus 4 moles adre istu. Now you convert that into particles. 1 mole ge Avogadro number adre istu case into 10 to minus 4 by 100. That comes to 6.02 into 10 to 17 cation vacancies in that. Now you have this. In calcium fluoride having fluoride structure, the coordination numbers of calcium plus 2 and F minus are respectively. So you must know one information here. In structures, solid structures, you call it as fluoride structure. There is one more type called rock salt structure. Rock salt structure. That structure is same as NaCl. How do you imagine this? Chloride ions occupy FCC positions. Andre, it is at the corners and it is on the faces. So 8 corners and 6 faces ali chloride occupy. Then where do Na plus go? They fill all octahedral voids. Octahedral voids. So that makes coordination number hege tagotivi andre every Cl minus is surrounded by 6 Na plus. Octahedral position adrinda 6 baruthe. Every Na plus is surrounded by 6 Cl minus. So this is the coordination number 6 and 6 equal 1:1 adike barodu. But look at the formula of calcium fluoride. So it is Ca(F2). Adu 1:2 nallide, but that structure is different from rock salt structure. Idanna fluoride structure antare, adanna torstini nanu. So how this calcium ions will be there? Calcium plus 2 ions, they occupy FCC. FCC positions andre ellel barutte. Just see, it is 6 faces and 8 corners. Then where do you find the fluoride ions? Very small. Fluoride ions being very small, they occupy all tetrahedral voids. So you know positions of the tetrahedral voids in the cube. El barutte andre ಒಂದು ದೊಡ್ಡ ಕ್ಯೂಬ್ ನ 8 ಸ್ಮಾಲ್ ಕ್ಯೂಬ್ ಮಾಡಿದಾಗ ಪ್ರತಿ ಕ್ಯೂಬ್ ಸ್ಮಾಲ್ ಕ್ಯೂಬ್ ಅಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಬರುತ್ತೆ. And this is surrounded by Ca plus 2, Ca plus 2, Ca plus 2 and Ca plus 2. Tetrahedral void andre tetrahedral orientation e barutte. Idu tetrahedral void. It is surrounded by 4 Ca plus 2. So coordination number F minus is 4. Then how do fluoride ions surround this andre? They surround this octahedrali. So 4, 5. So ಎಷ್ಟು ಕಡೆ ಬರುತ್ತೆ? It is, let me write, not this, actually octahedral alla. If there is a corner, for example calcium plus 2 illide andre, it is surrounded by all 8 directions alli, illi 3, 4, 5, 6. So 4 above ತಗೋತೀವಿ. Let me write F minus, F minus, F minus, F minus. One plane ನಲ್ಲಿ 4 ಇರುತ್ತೆ. ಇನ್ನೊಂದು ಪ್ಲೇನ್ ಕೆಳಗಡೆ ತಗೊಂಡ್ರೆ it is F minus, F minus, F minus, F. Look at this. ಇದನ್ನ full structure cube ಬರ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. Every calcium is surrounded by totally 8 fluorides. So you know coordination number of calcium would be 8. Coordination number of fluoride would be 4. So let us see the answer and working. Yes, it is 8 and 4. So now look at this explanation. In fluoride structure, calcium ions form FCC, the positions I told you. Then fluoride occupy all tetrahedral voids. Each calcium is surrounded by 8 fluoride, 4 above, 4 below. A cubic arrangement. Next, F minus, each F minus is surrounded by 4Ca plus 2. So that makes it coordination number of calcium 8, coordination number of fluoride is 4. Next question. The number of unit cells in 4 grams of X, atomic mass 40, which forms BCC lattice is. So here is the idea of number of unit cells to be calculated in 4 grams of X. So now we have this idea. I'll let you know. It is molar mass is 40. 40 grams of that X would contain Avogadro number of atoms. Then 4 grams would contain 1/10 of that, that is 0.1 Avogadro number of atoms. Then it is given that BCC. So for BCC, let me write BCC nalli ZS barutte. It is number of atoms per unit cell, which is 2. And every 2 atoms together make up 1 unit cell. And you have to divide this by 2 so that you get the number of unit cells. So let us see the answer. It is, yes, 0.1 Na by 2. Hege bandide nodi calculation. It is 40 grams. 40 grams is 1 mole. That contains Avogadro number of atoms. 4 grams is 0.1 Na. Then every 2 atoms count for 1 unit cell. Therefore, divide that total number of atoms by 2. You get the number of unit cells. So you come to the last question. Yes, this is the last question. If a metal of atomic radius 4 angstrom, it is the unit angstrom. So I'll write this. So it actually 0 mil barbeku pakdal bandide. Okay, fine. So a metal of atomic radius 4 angstrom crystallizes in BCC lattice, then edge length of its unit cell. So again, the idea is BCC. What you have to take is the body diagonal. Then how are the positions in body diagonal? 1 constant here, 1 here. So let me write it. 1, 2, and 3. So now you have this radius represented as R, 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 and R. So this body diagonal is taken as C, that is 4R. Then how it is related to the edge length of the unit cell? The edge length is A and the togondre. It is C square equals 3A square. Hege baruttade? 2 right angle triangle. One P square togondo amel togoti. So C square equals B square plus A square. So B square na navagle madidivi, it is 2A square. So that comes to 3A square. So C comes to, it is root 3A. And you substitute for C 4R. So 4R is root 3A. And what is given here is the atomic radius. What is to be calculated is A. So idನ್ನ ಇದರಿಂದ divide ಮಾಡಿದ್ರೆ ಬರುತ್ತೆ. So look at the answer and working. So it is 9.23 angstrom. So in BCC, edge length of the unit cell A ಅಂತ ತಗೊಂಡ್ರೆ atomic radius R, they are related as A is 4R by root 3, direct substitution. 4 angstrom into 4R by root 3. So it is 9.23 angstrom.